the Endace Packet Forensics Files with your host, Michael Morris. This episode's very special guest is Martyn Crew, Senior Director of Product Marketing at Gigamon. Martyn, welcome. Thank you for joining us. Tell us a little bit about yourself and your background.
Michael, thanks for having me, and hello everybody who's listening in. And it's great to be here. I was reflecting before we started this that, it's rare when you're doing a podcast like this. You've got people on both sides of the table with multi-year tenure at their respective companies, and where those companies have multi-year and real value-added relationship for their customers. So we really value the relationship with Endace. I'm glad to be here.
Well, we appreciate you joining. I'm excited to have your expertise because of your years of experience in this space. And what we talked about as a topic to really kind of focus on today for the discussion is really why log and metadata isn't enough for maintaining high levels of security, and ways organizations can reduce their costs and their security tools to really be more optimal, right? We're all under tremendous cost pressures. So with that as kind of the theme of our conversation, why is relying solely on network log and metadata insufficient for comprehensive network security? And kind of the follow-on, I know it's a long question. What are some of the limitations of these data types in terms of threat detection and response?
Yeah, okay. Well, you may have to remind me on the second part of that question, but let me talk about it first. So logs have long been regarded as sort of the gold standard. Providing it's being logged, I'm good. I can always go back to the log and determine what happened. But there's a lot of issues really with that line of thinking, and they really come from three areas. So the first is where you've got custom applications where the developers are deciding what they log. They may not be logging everything in the first place, so you've got a developer level issue. You've then got an operations level issue, which is during the course of applications running, if there are application performance problems, one of the things people often do is they decide to reduce the level of logging, to decrement the logging, in an effort to reduce the logging overhead and therefore boost performance. So that's the second issue. The third issue, and far and away the more important, is that when networks are attacked and successfully breached, the first thing that attackers usually do is they seek out the log files. And then they tamper with or just outright delete those log files to try and hide the footprints that they leave behind after a successful breach. Mm-hmm. So there's really three key weaknesses. And I think organizations increasingly realize that because of that, logs are not the immutable source of truth that they thought. The logs themselves are vulnerable, and they're looking for ways to address those issues.
No, you nailed it on the head there in terms of some of the weaknesses, and it is a changing mindset. So how, Gigamon obviously is tremendous at providing visibility across the network. So how is the availability of full packet data, comprehensive network traffic? How does it really enhance the effectiveness of network security and monitoring?
So I think, as we were just talking about, there is no one thing on the network that you can rely on to give you the comprehensive security that organizations need these days. Logs are part of it. We are not saying that logs are something to be disregarded. Logs for sure are an important part of this equation. However, there are many, many occasions, as you know, when organizations need to actually get down to the what happened. Look at the network packet, see where it originated, see where it was going, see what happened to it on its journey, and then to capture that so that if in a future event, if in the future an event has been detected, you can actually rewind and sort of figure out exactly what happened to that packet. So the logs are important, the packets are important, but also these days the metadata is very important because organizations just don't have the bandwidth on the networks, they don't have the storage, they don't have the capacity within tools to process raw packets in all instances. Mm-hmm. So increasingly we see it's that trifecta, it's the logs, it's the raw packet data, and it's the metadata that combine to give you the most effective security coverage.
Yeah, and it's you hit something key there. It's about connecting the dots between all those disparate sources of information and intelligence, really. So, Martyn, can you talk to us about a few use cases, and they can be certainly high level, where network traffic and and full packet data can be incredibly important to a SOC or a NOC analyst.
Yeah, you bet. So one of the things we do at Gigamon is, as well as providing the appliances and the software, we actually provide what we call Gigamon validated designs, which are these use cases that you referred to. We've got over 100 of them, and I promise, Michael, I won't go through all of them. But let's look at a few security oriented use cases that we see as being very important, and particularly today. So obviously, when we think about security, historically, we think about north-south security. We think about what's moving on to the network. To a lesser degree, we think about what's moving off the network. So an example of the what's moving off the network, where packets and detailed visibility become really important, is what's actually going out on the ports on the network. You know, there's this telltale sign of security issues on networks, which is what we call port spoofing, or, you know, on traffic moving across ports that they should not have access to. Right. So that's one of the very specific things where being able to see exactly what's happening at the traffic level, what port it's exiting the network on, is important. So that's a sort of a north-south use case. Mm-hmm. The other big thing that we're seeing more and more of is, as organizations move to increasingly complex hybrid infrastructures with not just on-premises, but with virtualized, and, you know, if I can say, both flavors of virtualized, both VMware and Nutanix, and multiple flavors of public cloud, getting visibility across this whole thing is a real nightmare. You know, the average Gigamon customer, it's now over 90%, has 5 or more such environments. Every environment has its own tools. The thing that's common across all of that is the packet. So you need to be able to see the packet moving across all of those different environments to really understand what's happening in that life cycle, and to really understand what's happening from a security as well as performance point of view. So with east-west, you know, this is a growing area that many of our customers are now kind of focusing in on as they move into these more complex environments.
No, those are some excellent insights, and you know, clearly the trend we can validate as well on where they're having troubles in some of these infrastructures. So one of the challenges we also hear a lot about is doing all this at scale. So what are some of the best practices you hear or recommend for customers to manage the scalability challenges of leveraging full packet data and network traffic across a global infrastructure?
Yeah, a really good point, because complexity, as I just described, in itself is one issue, but when you throw scale onto complexity, it really gets a very difficult challenge to manage and secure those type of networks. So this is one area where we do have really good perspective. You know, Gigamon's got 4,200 customers, 4,200 customers and a dog. 4,200 customers worldwide, and they're some of the largest, most demanding organizations there are out there. So the scale issue is something that we deal with all the time. So scale in terms of the traffic, I think, comes down to a number of things. One, you've got to sort of think about what do you need to see and in what level of detail. There are many ways to retain the full fidelity of the data that you are managing without seeing everything in detail all the time. You know, using metadata, for example, is one good approach, so that you can manage at the metadata level, and then where there are issues, you can actually dive down to the detail as necessary. So, I mean, that's one way to reduce the level of traffic moving across the network. And we see, even with simple metadata formats like IPFix, you know, significant reductions in data volumes. We also see, if you apply Gigamon's own application metadata, you know, maybe 90% reduction in the size of the flows and things going to tools and across the network. So there are definitely techniques that you can use to do that. You've got concepts like flow mapping, where you actually say this particular piece of information comes in on this port, it needs to go to that tool, don't let it meander around the network, just get it directly there. So there's lots of different ways to actually help with this issue. But fundamentally, these are all issues that need to be thought about up front. It's very, very difficult to architect scalability and security into a network after the event. These are all things that people really need to focus on up front as they're planning their network architectures.
No, totally spot on that. And building it with the resilient approach too is a key word I often hear from CISOs and stuff when I'm talking to them. So I think you're spot on that. Obviously we work in the area of capturing a lot of traffic, but we often hear customers talking about concerns of about storage and data retention challenges associated with the metadata, full packet data, and the variations. So what strategies or technologies can be used to manage these challenges effectively?
Yeah, I think we've discussed some of these already. So, I mean, the first thing is thinking about things in advance, putting a large scale network in place and then thinking, I don't have the visibility that I need, or I haven't got the right policies in place around data retention. Retrofitting those things into an existing network is very difficult. Getting them in place from the outset is critical. So I think, regardless of technology, that is one thing that all organizations should be and typically are mindful of. The other thing is how is the data being, let's go a different way on this. What is the data going to be used for? Mm-hmm. So, if you take that sort of functional view of what am I going to need to use this data for after I've captured it, that's going to really clue you into what level of data you need and how it's best processed and stored.
Yeah, we were talking offline yesterday and prep for this of the whole concept of a data swamp, right? People putting too much data into a data lake and the lake becomes a swamp because it's really unusable, right? So the use cases and workflows, I think you nailed as well. So
it's a big issue. I mean, we've all lived in this environment, and I think it's starting to change. But for the longest time, the SOC teams were very much, I need to see everything. I know you've got really clever software and it can do all this metadata stuff, but I need everything. Right. But I think increasingly two things have happened. One is people have realized that storing everything just costs an immense amount of money. I mean, as software vendors, not naming names, but as they've moved towards consumption-based models, it gets very, very expensive to support the store everything approach. And the other thing is what you said yesterday to me, which is the data swamp thing. Yeah, sure. You can retain everything for as long as you want. You can do it in, multiple levels of active and offline storage. You can bring in data lakes, security data lakes. You can do all of this stuff. But the bottom line is, no matter how much processing power you've got, the more data you store, the slower response times are going to be. And as we all know, SOC analysts can't wait. Yeah. Okay, I'll get you that tomorrow doesn't cut it when you're in the middle of a breach of some kind. So I think these are two big factors. Yeah,
that's key. Is the need for SOC analysts to be able to have accelerated incident response. I think you can't be sifting through myriads of files and storage if you can't search it quickly. So I think you nailed that as well. So how can organizations strike a balance between the benefits of having full network traffic, full packet data for security purposes, and the cost and resource implications, but again, being able to usability factor. So how do they strike a balance? What are some tips you'd suggest?
Well, I think a lot of it comes down to experience. I mean, people aren't new at this. They've been doing it for many, many years, in some ways, many decades. So there's a lot of knowledge that exists within our customer base on what the best practices are here. People know what is the sensitive data that they need to store. They know, it may be mandated, right? It may be compliance based, it may be regulatory, or it may be internal audit. So there may be standards around that. But then there's also common sense. I mean, we look at traffic on networks. I mean, we have this super useful tool, the application visualization tool, which knows the profile of over 4,000 of the most commonly used applications, and you can describe custom apps to it so that it can sniff those out. When we run that on networks for the first time, we're typically finding about 30% of apps that customers don't think are there. And this could be things like, it could be peer-to-peer networks, which are, just outright dangerous in the wrong hands. It could be that type of stuff. Or it could be shopping applications, or people are listening to Spotify, or people are listening to, ESPN or their favorite news channel.
Yeah.
So with that type of data, you get into the area of policy. So if an organization says, I'm living in the real world, people are going to use some of their home applications on my network, I'm going to allow it, but I'm going to be smart about it. Mm-hmm. So for example, if I detect a flow of data moving across the network, and I can look at the header and I can say, okay, it's Spotify traffic, it's ESPN, it's whatever, then once I've identified it and I know it's coming from an application which is safe, both in the sense of it's a trusted external application and on my network, I've said, yeah, we're going to allow this. At that point, you don't need to store all of the subsequent flow.
Yep.
Now, telling a story, we worked with one customer, and when they came to us, their issue was, hey, I've got this data retention storage. It started out where I was comfortably meeting my 30-day data retention goals, dictated by my GRC folks. It's now down to, I've only got 7 days storage there. Right. I need to go back. I need to buy more storage. And as we all know, storage, although we say storage is cheap, storage isn't cheap when it's designed around a specific function, like data forensics. So these guys were facing a multi-$100,000 million bill to add storage. So we were able, using the app visualization, app filtering capabilities, to actually look at what traffic was being piped through to the security tools and through those tools into the forensic storage. And we realized it was a ton of this type of data. It was the streaming data. It was operating system updates. It was all kinds of stuff that once it had been identified and applied, it was done. You don't need to go back and look at a Microsoft Windows update from 3 years ago. Doing that, we actually got that 7 days up to their 30-day mandated goal, and they did not need to go through a very expensive storage upgrade. Right. So, there's lots of stories we have that are similar to that, where, using the right techniques, you can help people reduce their tooling and storage costs.
No, that's a great example, and I don't know if it's the same story, but I know we had a joint customer together. It was a university environment where we were both in there, Endace and Gigamon, and you increased our look-back capacity by 40% by eliminating all the streaming traffic. Not surprising, a university has a lot of streaming traffic, right? Everybody's on Netflix and Prime and all the other services, so that's perfectly similar. So I don't know if that was the scenario that.
No, that's a different story. But I mean, you're right. I mean, we do a lot of business with universities, and as you say, when you actually analyze that traffic, I don't know what the ratio is, but I mean, it's probably close to 80-20 between what's junk and you really don't need to look at, and what is potentially a security risk.
Yep. No, that was excellent point. So multiple case studies of how we help each other in scenarios like that. So, Martyn, we mentioned it earlier. For our customers, listeners trying to manage a hybrid cloud environment, and the complexities of both on-prem and private and public cloud workloads, are there ways and suggestions you have for them to have visibility for both the physical and the cloud environments, and how can that work from your perspective?
Yeah, I mean, this is a critical thing. You can't have a situation where you have different levels of visibility into different platforms across an infrastructure. You've got to get to a common standard. And it's not easy to do. I mean, this is a journey that we at Gigamon started out on in 2016 with some of our first public cloud products. And there are issues because for the longest time, a lot of the public cloud vendors were like, yeah, you don't need to see packets. We're going to take care of all that stuff for you. And so them developing the software, whether it's the mirroring software or other ways to actually extract that packet level data, that has lagged. But we're now in a situation where all the major cloud vendors can provide that to us. So that's great because that means we can now apply all of the knowledge that we've built up over what's now 2 decades of understanding packet capture, or not in your sense, let's say traffic acquisition at the packet level, deep packet inspection, transformation of that, optimization of that, and then routing to the various tools. We can now apply 20 years worth of knowledge to that in the cloud as well as on premises and, of course, in private cloud virtualized environments. So we can now get an even playing field. So now when organizations deploy, for example, highly distributed or multi-tier applications, we can actually follow the packet with the same level of visibility anywhere it goes on that hybrid network. And that is, a very, very important, and from a security point of view, a very critical capability to have. Just to take one example, one of the things that we do in secure environments is we're often working with encrypted traffic. So we can decrypt essentially now anywhere across the network using various techniques. And then we can either re-encrypt or we can mask. So where you've got personally identifiable information, PII, or other sensitive data, you may not want to re-encrypt, but you may need to mask it. So there's no point having a network where you can see masked traffic on part of the network, but then it moves to a different sector on the network and you can no longer offer that capability. So you've got to have the visibility in the same feature level across all of these environments.
No, that's spot on. You're actually kind of getting my next question too, is you talked about decryption, which is one of the key functions you provide for us as well. Some others, data compression, dedupe, application filtering, we already talked about.
Yeah.
All of these things really lend to making more efficient storage and bandwidth, as well as not creating redundant traffic on the network, right? Compromising security. So how does all this come together to really, we mentioned it earlier, make the environment more resilient and more efficient, right? How does it kind of all tie together, I guess?
Yeah. So you're right. All of these things are totally interconnected. I mean, it's like a Jenga block, right? You can't touch anything within a network without it having implications to the 2 key things that you talked about: resilience and therefore network availability, and also the security side of things. So all of these things interconnect. So most organizations that we talk to are now very savvy to the mix of tools that they're using on the network. They're realizing, by and large, they've got far too many tools on the network. They're realizing that as they move to more and more platforms, they've got tools duplication. They've got, just take a simple example, a monitoring tool looking after one stack, a different monitoring tool looking after the other, but they don't have a look across ability. So they don't have the sort of comprehensive visibility that they need. So we're seeing organizations increasingly talk about, hey, how can I move to a single security stack, or at least a simplified security stack, where all the data, no matter where it originates from, gets captured, gets normalized, gets aggregated to where I can actually look at everything in total, and then can be optimized based on what that data is going to need to do in the next stage of its journey. So, I mean, that really is the sort of the capability that we bring to the table.
Yeah.
But as you said, it's complex. I mean, we recently worked with one organization. It was a service provider organization, a global at scale. They had over 500 security tools. How do you start to rationalize that environment? How do you create resilience in an environment that's as fragmented as that? So it's a very difficult challenge. Technology vendors like you and I, we have a role to play in that, but
Yep.
a large part of it is down to the internal experience, the disciplines, the policies, and the things that are put in place to prevent those situations developing in the first place, where you end up with this inherently fragmented and very difficult to manage architecture.
Yeah, no, that's an excellent example of the the 500 tools, and you and I in this space, we're seeing a lot of tool vendors, what were firewall vendors moving into the NDR space, and you've got NDR and AI tools, right? So now you've got duplicate efforts of just functionality. So I think you hit that on the head. Martyn, my last question, and
Yeah.
again, I ask you to, we always ask our industry experts like yourself to, put on your prognosticator hat for a second, and what's one thing you'd suggest to our listeners to be on the lookout for, think about over the next 6 to 18 months, and that's an eternity in the cybersecurity world, but something to think about, a trend that you see on the track, that they might want to be paying attention to.
Yeah, so I think inevitably it's zero trust. I mean, zero trust is now all around us. Whether it's within government where it's being mandated, whether it's in enterprise boardrooms where it's being discussed and sort of pushed top down. We've got to rethink our next generation security architecture. We've got to throw away a lot of the concepts that 30 years of IT have been based on, which is largely concepts of implicit trust, that once I'm inside the network, I'm obviously good because I'm inside the network.
Right.
These are huge challenges with many implications for organizations. And again, as technology vendors, there's so much that you and I can do here. But a large part of it does come down to organizations adopting a totally different mindset. And it isn't just about tools and technology. It's about culture within an organization. And I think that is going to be the single biggest challenge that the zero trust vendors, which includes both of us now, that we have. Changing user behavior is non-trivial. And particularly when it has the security aspect to it, it becomes a major issue. So how do we architect applications? How do we deploy applications? How do we use applications? How do we monitor applications? All these things have cultural overtones to them within organizations, and it varies from organization to organization. All of those are going to need to change. So I think zero trust is going to be a major issue. And I think we're going to see it go through a number of different phases of thinking. Where you've got government and government's got the ability to mandate this, I think you may see fairly pure play zero trust architectures deployed. But outside of that, I think we're going to see all kinds of modifiers and the sort of weasel words coming in. A lot of existing security initiatives are going to be rebranded as a zero trust initiative to make sure that the CEO can say to the board, yeah, we're going zero trust. So I think there's all kinds of modifications that are going to be applied to this. But I do think zero trust is a conversation that's going to dominate the industry for the next couple of years.
No, I completely agree. And the number one theme I hear about it and talk about is really, it's a journey. It's an evolutionary journey. It's a, not, you hit it on the head, not just tools and processes, but people and training and education in a lot of ways. So, Martyn, thank you for taking time out of your busy day. I know you are buried with a lot of stuff, so I really appreciate you sharing your tremendous expertise in how to better secure networks. We'd ask our listeners to tune in next time for another edition of the Endace Packet Forensic Files. For more information about Endace's network packet capture platform and our integrations with our fusion technology partners like Gigamon, please go to endace.com. Martyn, again, thanks for taking the time.
It's always fun. Thank you, Michael.
All right.